Space is vast. It stretches out in all directions, an endless expanse of stars, planets, and galaxies. It is full of mystery. Every corner of the universe holds secrets waiting to be discovered. In 2017, we got a glimpse of that mystery up close. It was a year that would change our understanding of the cosmos. A strange visitor came calling from beyond our solar system. We called it Oumuamua. The name is Hawaiian, chosen to reflect its unique journey. It means a messenger from afar arriving first. It was fitting, as this object was unlike anything we had ever encountered before. Oumuamua was the first object of its kind we had ever seen. It was a true interstellar traveler, a wanderer from another star system. Astronomers at the University of Hawaii first spotted it. They were the first to lay eyes on this cosmic enigma. They were using a powerful telescope called Pan-STARRS-1. This advanced instrument allowed them to detect objects far beyond our solar system. It wasn't like anything in our solar system. Its shape, its speed, and its trajectory were all unprecedented. It was on a trajectory that could only mean one thing: it came from another star system. This was a visitor from the depths of space. The discovery sent ripples of excitement through the scientific community. Researchers and astronomers around the world were eager to learn more. Here was a chance to study something truly alien. It was an opportunity to gain insights into the nature of other star systems. It was a chance to learn about the building blocks of distant worlds. Oumuamua offered a rare glimpse into the materials that make up planets beyond our own. One of the first things that struck scientists about Oumuamua was its shape. It wasn't spherical like many asteroids and comets. Instead, it was long and thin, like a cosmic cigar. Observations suggested it was at least 10 times longer than it was wide. This made it unlike anything we had ever seen in our own solar system. Some astronomers estimated it to be the size of a skyscraper. Its strange shape sparked intense curiosity. What could have created such an elongated object? Was it a common shape for interstellar objects? Or was Oumuamua a cosmic outlier? The origin of Oumuamua was a complete mystery. Scientists could trace its path back to interstellar space. However, its exact home star system remained unknown. Some theories suggested it was a fragment from a larger object. This object could have been torn apart by gravitational forces in its home system. Others speculated it could be a cosmic dust bunny. This bunny would be a clump of dust and ice held together by weak forces. Despite the lack of definitive answers, one thing was clear: Oumuamua was a true space traveler. It had journeyed for millions, if not billions, of years before stumbling upon our little corner of the galaxy. As Oumuamua whipped around the sun and began its journey out of our solar system, astronomers noticed something strange. It wasn't behaving as predicted. Gravity was pulling it, yes, but something else was giving it a push. Oumuamua was accelerating. This acceleration wasn't huge, but it was definitely there. And it couldn't be explained by the gravitational pull of the sun or any other known planets. This unexpected behavior only deepened the mystery surrounding Oumuamua. What could be causing the strange acceleration? The scientific community was abuzz with new theories, outgassing a possible explanation for the boost. One of the leading theories to explain Oumuamua's acceleration was outgassing. Comets, for example, release gas and dust when heated by the sun. This creates a jet-like effect that can propel them like a rocket. Could Oumuamua be doing the same? Perhaps it was venting material from beneath its surface as it was warmed by the sun. This could explain the observed acceleration. However, there was a problem with this theory. Scientists didn't detect any signs of outgassing. If Oumuamua was releasing gas, it should have been visible in the telescopes. Yet, there was no tail, no coma, no telltale signs of outgassing. The sun's push, solar radiation pressure, and Oumuamua's movement. The sun, our closest star, emits a constant stream of energy in the form of light and other radiation. This energy travels across the vast expanse of space, impacting everything in its path. Another possible explanation for Oumuamua's unexpected acceleration was solar radiation pressure. This phenomenon occurs when photons from the sun exert a force on objects they encounter. This is the force exerted by sunlight. Although it might seem negligible in the vacuum of space, even the smallest forces can have significant effects over time. It's a very weak force, almost imperceptible in our daily lives. However, in the vast emptiness of space, where there is no air resistance or friction, this force can become quite influential. But it can have a noticeable effect on small, lightweight objects in space. Spacecraft and satellites, for instance, often have to account for this pressure in their navigation. Could Oumuamua be so lightweight and porous that even the gentle push of sunlight was enough to alter its course? This question intrigued many scientists and astronomers. Some scientists believed this was a possibility. They hypothesized that if Oumuamua had a very low density, it would be more susceptible to the effects of solar radiation pressure. This theory was bolstered by the fact that Oumuamua's brightness varied significantly as it tumbled through space. The variations in brightness suggested that it was rotating and had an irregular shape. This suggested it had an irregular shape and might be quite porous characteristics that would make it more susceptible to solar radiation pressure. If true, this would mean that the sun's gentle push was enough to change its trajectory, providing a fascinating insight into the dynamics of interstellar objects. A turning point in our understanding of interstellar objects. The discovery of Oumuamua and its unexpected behavior marked a turning point in our understanding of interstellar objects. It showed us that our solar system is not isolated. It's a cosmic shooting gallery with objects from other star systems passing through. Before Oumuamua, we could only theorize about the composition and behavior of such objects. Now, we had actual data. Data that challenged our assumptions and raised more questions than answers. Oumuamua showed us that the universe is full of surprises. It reminded us that we still have much to learn about the cosmos and the objects that inhabit it. Could it be alien technology? The possibility of Oumuamua being an alien artifact was also considered. While this was the least likely explanation, it captured the public's imagination. The strange shape, the unexpected acceleration, the lack of outgassing, it all seemed so unusual. Could Oumuamua be a derelict alien spacecraft, a probe from a distant civilization? While this idea was intriguing, there was no scientific evidence to support it. Extraordinary claims require extraordinary evidence, as the saying goes. And in the case of Oumuamua, the evidence pointed towards natural phenomena. Searching for answers, future missions and observations. The brief encounter with Oumuamua left scientists wanting more. This mysterious object, with its unusual trajectory and speed, sparked a wave of curiosity and speculation. It raised tantalizing questions about the nature and origin of interstellar objects. Was it a comet, an asteroid, or something entirely different? Questions that could only be answered by studying more of these cosmic visitors. Each new discovery could potentially rewrite our understanding of the cosmos. Fortunately, new telescopes and sky surveys are coming online. These advanced instruments are designed to scan the skies with unprecedented precision and depth. These will increase our chances of finding more interstellar interlopers. The more we find, the better we can understand their origins and trajectories. There are even plans for missions that could rendezvous with such objects. These missions would be groundbreaking, allowing us to study these visitors in their natural state. They could study them up close. By collecting samples, we could analyze their composition in detail. These missions would allow us to analyze the composition of interstellar objects. Understanding their makeup could provide clues about the conditions in other star systems. We could learn about their formation and history. Each sample could tell a story of its journey through the galaxy. And who knows, we might even find more clues about the possibility of life beyond Earth. The search for answers continues, and with each mission, we get closer to unraveling the mysteries of the universe. The universe is full of surprises. Oumuamua may be gone, but its legacy lives on. It serves as a reminder that the universe is full of surprises. It is a vast and mysterious place. We're just beginning to explore its wonders. The next time you look up at the night sky, remember Oumuamua. Remember the strange visitor from a distant star system. And remember that somewhere out there, countless other mysteries await our discovery. The universe is vast. It is full of wonders, and we are fortunate for its mystery. Keep looking up.